Lesson 2.5, Rational Zeros of Polynomial Functions. The remainder theorem states that if we have a function, a polynomial function, and we divide it by x minus k, then the remainder is f of k. Which is kind of interesting. If you think about it graphically, if k is right here, and we divide our function by x minus k, then it's saying the remainder is the y value. So we could find the y value of a function using synthetic division. So let's use the remainder theorem to evaluate this function for f of negative 1. So we want to plug in a negative 1. So we're going to put the negative 1 in a box, and then the coefficients, so we're just doing synthetic division. Make sure you have all the powers of x. We have 3, 2, 1, 0. Bring down the 4, multiply, add, and multiply, add, and multiply, and add. Run a number, so that's the end. So, according to our remainder theorem, our remainder is the value of the function. So f of negative 1 is 1. Which you could also get by simply plugging in a negative 1 for all the x's, and you'd get 1. However, if we were doing something with a bigger number than negative 1, it'd be faster just to do the synthetic division than straight substitution. We also have the Rational Zero Theorem. Because back in the day, when you were trying to solve these polynomial equations, there's no calculators, no graphing calculators to easily find x-intercepts and things like that. So you pretty much just had to try a whole bunch of numbers. You know, just guess and check. Well, there's an infinite number of numbers to guess. So, somebody discovered this Rational Zero Theorem, which says if you have a polynomial, the rational zeros are the ones that can be written as fractions, are in the form of p over q, where p is factors of the a0 and q is factors of the an. That'll still give you a long list of numbers, but it'll be way shorter than an infinite number of numbers. So let's find all the rational zeros, given that x plus 1 is a factor. Well, here's the process. We're going to find all the p's. P's are factors of the 8. So that's 1 times 8, 2 times 4, and I think that's it. And then q's are factors of the leading coefficient, which in this case is just 1. So the p's over q's are just 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So which one of those do you want to choose? Well, they told us x plus 1 is a factor, or x minus a negative 1. So we could use that. Notice that is here in my list. And do synthetic division. Don't forget to check for placeholders. We have x cubed squared to the first. Okay. Bring down the 1, multiply, add, multiply, add, multiply, and add. Alright, notice we got a 0. That means the negative 1 is a 0. Now it was x cubed, so our depressed polynomial is x squared. We could probably solve this, make it equal to 0 because we want the zeros. Let's try factoring. To get the 8 could be negative 4 and negative 2. That adds up to make the negative 6. And then each factor equals 0. So x is 4 and x is 2. Notice we have the 2 and the 4 in our list. So all our zeros are negative 1, 2, and 4. Notice it is x cubed, and we have 3 zeros. Let's try another one. Alright, let's go ahead and do the p's and the q's. So p's would be factors of the constant term, or the 14. So that's 1 times 14, or 2 times 7. I think that's all. Q's are factors of the leading coefficient, so that's just 1. So the p's over the q's are just 1 over 1, 2 over 1, 7 over 1, and 14 over 1. Now, which one of those shall we choose? Well, I told you x plus 2 is a factor, or x minus negative 2. So we'll try negative 2. Notice that is an option from my list. Coefficients is 1x cubed, negative 7x squared, negative 11x, plus 14. Bring down the 1, multiply, negative 2 times 1, and add. And we multiply negative 2 times negative 9, and then we add. We multiply negative 2 times 7 is negative 14. Then we add, and we got a 0. Perfect, we got a 0. Now it was x cubed, so now it is x squared for a depressed polynomial, x squared minus 9x plus 7. And we want to find all the zeros, so make that equal to 0, since it's quadratic, and see if we can solve it. Let's try factoring. Get x squared is x and x. To get 7 is just 7 and 1. But that does not add to make 9. And we have no other choices to make 7. So it looks like we're going to have to use the quadratic formula. There's negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's negative a negative 9. Negative 9 squared minus 4 times a times c for 2 times a. So it's 9. Alright, inside the square root looks like it's 81 minus 28. Which gives us 53. We can't simplify the square root of 53, so this is our answer. So our zeros are negative 2 and 9 plus the square root of 53 over 2 and 9 minus the square root of 53 over 2.